Okay, so this video is still on our linear motion problems that we're having to do. So number 30, reading the problem, we know that it starts from rest. It's an airplane. Has a constant acceleration of this, and this occurs over a time of 30 seconds, at which point it leaves the ground. Its initial position will be 0 because it didn't state otherwise. And we're looking for its final position and its final velocity. Okay, I don't see anything tricky to this. I cannot imagine that you would have a hard time with this. You should be able to do this one easy. Okay, we're given acceleration and we're given time. That opens up a lot of doors. So you should be able to pause your video, pick out your equations, show your work, etc. Okay, make sure you're using crosses, units, cancellations, all that good stuff. Okay, so if you're finished with the problem, again, I don't know the answer because I don't have the answers out in front of me. Actually, I do have the answers, so we'll look at it and make sure it's right. Let's see here. So for x, I think I can just use this equation, and it's going to be oh so easy because x naught is 0 and vx naught is 0, and anything times 0 is going to be 0. I do see a lot of people mark out vx naught, but they leave t. But you can't do that because t is multiplied by 0, so you got to mark out the whole thing. So then x should just be equal to 1/2 at squared, and then vx is simply equal to vx naught plus a times t. Make sure you show your units, okay? If you're showing your units, this one should look like this. On crosses, you should have 2 crosses. You're going to put your 1/2 here, or 0.5. You're going to put your a here, and you're going to put your t squared here. Okay? Everything has an upstairs and downstairs. Whether you use it or not is up to the number itself and where it's at in the equation. Here, I would have this. Oh, but vx naught's 0, so I can mark it out. So I'm only going to have a cross that looks like this. Show your units, all that good stuff. So, let's see if you got number 30 right. You should get somewhere around 1,350 meters for A, and for B somewhere around 90 meters per second. Okay? Alright, moving on to 31. We're getting into vertical motion now, so instead of putting down x's, we're going to put down y's. So for number 31, it's really not hard, but your Vy naught is 0. It says it's dropped from rest, I think. Let me turn to that problem. A brick is dropped from a high scaffold. If you just drop something, its initial velocity is 0. If you're not throwing it down or throwing it up, your initial velocity is 0. Okay? It says, what is the velocity after 4 seconds? And how far does the brick fall during this time? Okay. So since our vertical acceleration we have discovered in class is always going to be -10 meters per second squared on the earth, okay, we're going to go with that. That's what we're going to put for acceleration. It's negative because it's speeding up while going down. Speeding up while going down. Negative acceleration. But what it's doing is it's gaining 10 meters per second for every second that it's moving. So if it starts at 0, how many times does it gain 10 meters per second? 4 times, right? It gains 10 meters per second for each second that it's moving. So I can tell you right now, we should get a -40 meters per second here. Okay? Sorry, I kind of gave away the punchline there, but find an equation and test that out. Okay? As far as y goes, you got to find an equation for that. So look at your equations. You're using 1, 2, or 3, but every time you see an x, it should be a y. Okay? We're thinking vertically now. Okay, so do that and check your answers. Moving on to 32. Aha, I like this problem. Okay, on 32, it's a little bit harder. We have a tennis ball is thrown straight up with an initial speed of 22.5 meters per second. So I'm making it a positive velocity because it's 22.5 meters per second up, and that's a positive direction. And it's caught at the same distance above the ground. So it goes up, and then it's caught at the same height above the ground. Okay, so let's say that this is our initial position, y0, and that's 0. Okay? And then the question is, how high does the ball rise? So what is y right here? And then how long is the ball in the air? Okay, total. How long is the ball in the air? Okay, so let's take a look at this. Here's how I want you to start thinking about this problem. I'm going to erase this half of the problem. We're only going to look at this half, because for this half, I know Vy0, and I know the vertical velocity at the top. It's going to hit 0. It's slowing down this time. Instead of speeding up, because it's not falling down, it's slowing down 10 meters per second for every second that it's going up. So its acceleration is still negative, because it's going up, which is positive, but slowing down, which is negative. So we still have a negative acceleration. Okay, so these are the things I know, and I need to find the vertical height. I'm going to give you a really quick shortcut on finding time here. It started at 22.5 meters per second. It loses 10 meters per second each second that it's going up. Now, if it had started at 20 meters per second, and it loses 10 meters per second for each second, it would take it exactly 2 seconds to get to the top. It would lose 10 meters per second in 1 second, and it would lose the next 10 meters per second in the second. Okay? So it's not going 20 meters per second, it's going 22.5. So it's going to take it exactly 2.25 seconds to get to the top. Okay? Think about that. Now, go ahead and check it out if you want to. Vy equals Vy0 plus a times t. You can solve for t with this equation because you know everything in it. Vy is 0, right? So I'm going to subtract Vy0 to both sides. And then I'm going to divide by a, and that's going to give me t. Show your work, cross format, negative 22.5, I'm putting a negative because I subtracted it to the other side, meters per second, divided by negative 10 meters per second squared. On the bottom goes to the top. Okay? This second cancels out this cancels out this, and I end up with a positive number. Time can't be negative, so you should never get a negative time. And I end up with 2.25. Okay? Now it takes it 2.25 seconds to get to the top. The question is, how long did it stay in the air altogether? So whatever 2.25 is times 2, because it's going to take it just as much time to go up as it does to come down. Okay, so whatever that is times 2, so that's 4.5 seconds it looks like. Okay, so for y, I want to know how high up it went now. Still, I'm only looking at this first half. So see if you can find an equation to solve for y and you know everything else in it. Okay, check your answer. Good luck on that one. Okay, 33. Ooh, I'm at 9 minutes. I'm going to stop the recording.